All right, this is a reproduction of the handout that's online, except that I've removed the section over here that has the work. I'm going to rework it for you. All right, so as we look, first of all, this is an acidic reaction, and we know that because it doesn't have the word basic typed out beside it. When you have a problem that does not have, if you look at each one of the parts, it does not have a plus or a minus in it, then as a superscript, then you have to write a net ionic equation. To do that, you'll use your solubility rules. So I'm going to take this equation, I'm going to do a net ionic equation, and according to solubility rules, sulfates are soluble. So we'll say Sb plus 3 plus SO4 minus 2 plus K plus, because all of the group 1 are soluble, plus MnO4 minus 1 plus water. We can basically ignore the idea that it has water because that's going to come back in the end. So I'm not going to worry too much about that it has water in it, but that's it, so just write it. And then I'm going to look at this acid here, and the rule says if the number of oxygens is 2 greater than the number of hydrogens, then it is soluble, or it's strong. And this one is not strong, so I'm going to keep it together, H3SbO4 plus, and then I'm going to have Mn plus 2 plus SO4 minus 2. Now we look for spectator ions. If you remember that discussion from the first 9 weeks, spectator ions are those things that are exactly the same on the left and the right of the yield sign. So SO4 is a spectator, and so I can mark out SO4. I can also mark out K plus because it's, whoops, I forgot to duplicate, but plus K plus SO4 minus 2. So all the SO4s and all the K's are gone. So now I have Sb plus 3 plus MnO4 minus plus, I'm just going to, H2O yields H3SbO4 plus Mn. And that's the plus 2. It's very important that you put the minuses and the pluses as I put them. You don't leave those off, because the whole preface of this type of problem is to know the charge. Now, we're going to find the charge of each element. You have a page in the Redox instruction that reviews you on how to do this. But and we've done it in Chemistry 1, we did it again in the first semester, so I'm going to hurriedly go through this process. Well, Sb is a plus 3, we can see that. MnO4, I know that oxygen's a minus 2, but I don't know what the Mn is. So oxygen being a minus 2, and there are 4 of them, that gives me a minus 8, and I set it equal to the charge, which is minus 1. So what do I add to minus 8 to get a minus 1? Well, a plus 7. So that's a plus 7. Down here, the H is a plus 1, and there are 3 of them, so that's plus 3, plus, I don't know what the Sb is, plus 4 times minus 2, or add the charge of the oxygen, which is 4 times minus 2 minus 8, and since there is no charge written up here, the charge is 0. So what do I add to plus 3 to get minus 8? Well, plus 5, so that must be a plus 5. Now I'm going to erase this right here because that kind of interferes with what I'm trying to show you. Alright, now I'm looking at and I'm concentrating on those things that change their charge and whatever atoms are glued to them. So I'm going to write 2 half reactions, pick one of the elements, and the first element I see is Sb. So Sb plus 3 yields H3SbO4. And then it says pick one of the elements, add electrons to the side. Actually, I'm going to change this so that this becomes number C. and this becomes Z. So I'm going to balance all of the atoms except hydrogen and oxygen. So the Sp, I have to look at it. If I don't look at it, then I'm going to end up making a lot of mistakes over the process of working these types of problems. The Sp, they are balanced, so now I can go on to add electrons to the side with the largest oxidation number. Well, I have plus 3 and I have plus 5, so I'm going to add 2 electrons to that side. Check yourself, plus 3 equals, the yield is equal, plus 5 minus 2. So plus 3 equals plus 3. Now it says to balance the oxygens by adding water. So I have 4 oxygens over here, so I have plus 4 H2O. And then it says to balance the hydrogens by adding H plus. Well, I have 8 hydrogens here, and I have 3 here, so I'm going to need 5 hydrogens. That way I have 8 hydrogens on both sides. Now I'm on step 4, so I'm going to repeat step 3 for the next element. That would be Mn. So I have MnO4 minus, and that's a plus 7, yields Mn plus 2. Balance the atoms other than hydrogen and oxygen. The Mn's are balanced. And then it says to add electrons to the side of the bigger. So that would be 5E minus. Minus 5 plus 7 equals plus 2. So that's balanced. Now, I want to balance the oxygen by adding water. So I need 4 H2O. And then balance the hydrogens by adding H plus. And I need 8 of them. So that balances that. Now I'm down to step 5. Step 5. The number of electrons given up has to equal the number of electrons needed by the other. So if this Sb right here is going to give up 2 electrons, and this needs 5 electrons, you can't take what's not there, and you can't give up unless there's somebody there to take it. So they have to be equal. The common denominator then would be 10. So we're going to multiply this equation by 5 and this equation times 2, because I'm trying to make these equal and on opposite sides. So we have 20 H2O plus 5 Sb plus 3 yields 5 H3 SbO4 plus 10 E minus plus 25 H plus. Now I'm going to multiply by 2 on the second equation, so that's going to give me 16 H plus 10 E minus plus 2 MnO4 minus yields 2 Mn plus 8 H2O. Now, I have to add the equations algebraically and reduce when necessary. Well, immediately the electrons are on opposite sides, so I can reduce those and get rid of them. Now I also notice that I have water here and water here. I have 8 here, so I can get rid of all of those, and I will be left with 12 here. On my H's, I have 16, and I have 25. So I can get rid of 16 of them here, and that will leave me with 4, 5, 9 here. All right, so now I'm going to add the 2 equations. I'm just going to start here, write down what's here, and then come down and write down what's left here, then do the same thing on the other side. So I have 12 H2O plus 5 Sb plus 3 plus 2 MnO4 minus yields 5 H3 SbO4 plus 9H plus do that plus 2 Me. Now to check, I want to check my H's and O's. I have 24 H's here, and I have 15 plus 9 is 24. My O's, I have 12 plus 8 is 20. And over here I have 5 times 4 is 20. And the last check is to check the charges. So let me erase this, and we'll check the charges. Over here I have a 0 plus 5 times plus 3 is 15, plus a minus 2 equals 0 plus 9. That's a plus 2. That's right, and that's why it's important to write it. 4. So I have 13 over here, positive 13, and over here I have a positive 13. And that's your final check. And if your charges equal and your hydrogen Johnson equal, you're pretty well assured that everything is balanced. So the final box answer, and this answer should be written on the original handout that you're working on. You can use the space between the problems to work, do all this work, but this answer has to be on that page. So you can either do the work on your own sheet, or you can do the work on the page that I've given you, and there's plenty of room to do this. Okay, so now basic problems. These basic problems will have basic typed on the sheet, so you know when to use these rules. All right, when you have a basic problem, it's basically the same rules that we've already done. Pause again. Okay, little technical difficulty. Wasn't showing all of the steps, so I wanted to go back and make sure we did that. Again, when you write a net ionic equation, you're going to use the solubility rules, and you don't have to do this if your problem already has pluses and minuses in it, which is the first 2/3 of your assignment. But here we have Br, which is a molecule, and it does not separate, so Br, there's no rules for a molecule, plus calcium, it tells you that hydroxides group 1 and 2, I believe, are strong, so that would be Ca plus 2 plus OH minus. And then you go to calcium bromide, and bromine is a group 17, so it's soluble for the rule, I think, number 3, plus Br minus, plus Ca plus BrO3, and that's plus 2, and that's a minus 1. All right, now we need to cross out any of the elements that are identical, and that would be your spectator ions would be calcium. So now we're left with Br2 plus OH minus plus yield Br minus plus BrO3 minus 1. Now, you'll find this happens frequently, that the Br, you have a bunch of atoms of Br. There's not just one molecule. We're talking about moles of molecules. So some of the Brs will be reduced to be Br negative, and some of them will be oxidized to be the Br in the BrO3. Over here, the charge of the Br is 0, because there's no charge written by it. The oxygen and hydrogen are always plus 1, minus 1. The Br here is a minus, but I don't know what the Br is here. So I would say blank minus 3 times minus 2 is a minus 6 equals minus 1, which is the charge. So what would I have to have? Well, plus 5. So that's plus 5. And again, those rules are written for you on one of the sheets of this handout. So now we are going to write two half reactions. Pick one of the elements that changed its charge. So Br2 with 0 charge yields Br with a minus charge. Now it says to add electrons to the side with the largest oxidation number. So again, I'm going to make this the C step and this the B step. So we're going to balance all the atoms except hydrogen or oxygen. So we only have Br, but we have two of them over here and only one on this side. So 2 and 1, we'll have to put a 2 here to balance that. Now we want to add electrons to the side that has the largest oxidation number, which 0 is larger than -1. And I have 2 times 0 is equal to 2 times -1. So that's -2. So I have to add 2 electrons because I have 2 atoms and each one of them needs to gain an electron. So each one of these has to gain an electron to produce 2 of the Br with a minus charge. That's what I said earlier in the first part of this, was that you have to balance all of the atoms except the hydrogen and the oxygen.
These lights were to happen to go off in the building about 2.
All right, now, this one, and since it has no, I could go down here to where it says balance oxygen. By adding has no oxygen, has no hydrogen, so I'm done. Now I'm going to do the other half reaction, which is going to be the Br2 with 0 charge yields BrO3 with a -1 charge, and that charge is a +5. So balance all of the atoms except hydrogen and oxygen. Br, there are 2 here and 1 here. I have to have a 2 to balance those. Now I'm going to balance the electrons by adding electrons to the side of the bigger. Well, I have 2 times 0 equals 2 times +5 is +10. So it's going to take 10 electrons for that to happen. Now I have 0 is equal to 2 times +5 minus 10 is equal to 0. Now this is the only thing that's different about balancing a basic equation. D says balance the oxygens by adding twice as many OH negative as you think you need, unless you are balancing oxygen atoms in hydroxide. If this were hydroxide, I would simply add hydroxides over here and be done with it. But it's not. So I'm going to add, I think I need 6 oxygens. So instead of putting 6 OHs over here, I'm going to put twice as many as I think I need. So 12 OH minus. Again, you're going to add twice as many OHs as you think you need to balance the O's. I have 6 O's. I think I need 6 OHs. I'm going to add 12 instead of 6. Then the next says balance the hydrogen atoms by adding water. Well, I have 12 H's over here, so I'm going to need to put 6 H2O. It's hard to read that, but 6 H2O. Now let's check the oxygen since I added some more. I have 12 oxygens here. I have 6 here, plus 6 more in my H2O. So that's 12. So that's why we add twice as many as we think we need. So we've done both of our half reactions. Now the number of electrons still have to equal the number given up. I have 2 and 10, so I'm going to multiply this times 5. So I have 10 E minus plus Br2 yields 10 Br minus. Now I usually draw a line through this so that I don't get confused when I'm adding the two of the 2 half reactions. So now I'm going to add the 2 half reactions and I'm going to reduce where I can. Well, I have 10 E's and I have 10 E's. The waters, there are no waters that I can cancel out like I did in the previous example. In the OHs, there are none. But you will have times when you have those. So I'm going to have 12 OH minus plus Br. Whoops. Now, let's look at that. I should have 5 right there. I forgot to do that. So let's erase right here and go back. Here we've got 5 times 2 and 5 and 10. Now, how many BRs are there? I've got 12 OH minus, and then I have how many BRs? 6 BR2, because I have to combine those. Yields 2 BRO3 minus plus 10 BR minus plus 6H2O. So let's do our checks. We have 12 O's, and we have 6 plus 6 is 12 O's. We have 12 H's, and the main thing is do our charges balance. I have 12 minus 12 on this side plus 0 yields minus 2 plus, won't be a plus, it'll be a minus 10 plus 0. So minus 12 equals minus 12. So this is balanced. So this is my box answer. And that's what has to be written on the page. If you need help, you don't have your charges don't balance in the end, bring me your work and I'll help you with it if you need it. So good luck.